Assalamu alaikum everyone. In today's class, I will show the second order derivatives. Earlier, I have explained how to differentiate algebraic terms, logarithmic terms, and the trigonometric terms. Today, I will show you the second order differentiation. Means, firstly, I have explained just one single term, how to differentiate one term. Now, today, I will teach you how to differentiate twice. That's why it is known as second order derivatives. Right, second order derivatives. So in second order derivatives, we are differentiating twice. That's why it is known as second order derivatives. Now let y is equal to f of x. Let y is equal to f of x. Name this as equation 1. Okay. Now differentiating y with respect to x, we get dy by dx is here, f dash of x divided by dx is f dash of x. Now name this one as equation 2. So see here, if f dash is differentiable again, then we may again differentiate this equation 2. How? See, differentiation of equation 2 once again, d by dx of dy by dx is equal to, we get f dash of x. This implies differentiating y with respect to x, we get dy by dx is equal to f dash of x. Okay. So if f dash of x is again differentiable, we may differentiate equation 2 again, then we get d by dx of dy by dx is equal to f dash of x. Now this implies d2y by dx square is equal to f double dash of x. Name this one as equation 3. So see here, differentiation of y with respect to x, we got dy by dx. Again differentiation of dy by dx with respect to x, we got d2y by dx square. So d2y by dx square is known as second order derivative of y with respect to x. Or we can say the second order derivative of y, the second order derivative of y with respect to x is denoted by d2y by dx square. So it is known as second order derivative of y with respect to x. And here, see here, the f dash of y, f dash of x is the differentiation of f of x in the right hand side. Now f double dash of x is the differentiation of f dash of x. So that means the differentiation of f of x is uh, the differentiation of f of x is second order differentiation of f of x is f double dash of x. So here differentiation of f of x on right hand side, this one is f double dash of x. We got it is called, I'm writing here, second order derivative of f of x, and it is denoted by, it is, denoted by, f double dash of x is denoted by y double dash or y2 or dr. So I'm explaining it once again. Consider y is equal to f of x. Name this one as equation 1. Differentiation of y with respect to x, we get dy by dx is equal to f dash of x. Name this one as equation 2. Suppose f dash of x is differentiable. Now we may again differentiating equation 2 with respect to x. Then we get d by dx of dy by dx is f double dash of x. Or we can say this one differentiation of this will become d2y by dx square is equal to f double dash of x. Name this one as equation 3. In the left hand side, differentiation of y with respect to x, we got dy by dx. Now again differentiation, we got d2y by dx square. This one is known as, this term d2y by dx square is known as the differentiation, second order differentiation of y with respect to x. Okay. On LHS side. On RHS side, f dash is the differentiation of f of x with respect to x, and f double dash is the differentiation of f of x. So f double dash is known as the second order differentiation of f of x, and it is denoted by y dash, y double dash or y2 on dr y, means we are differentiating once again. So this one is known as the second order derivatives. Now I will show you some example based on second order derivatives. Now write example. If you know the differentiation of the algebraic terms and trigonometric sum, logarithmic term, then we can differentiate once again. It is easy if we know the differentiation formula of the algebraic term and logarithmic term and the science trigonometric term. Then we can easily solve it. So write down examples. So write first example. Find the second order differentiation of, find the second order differentiation of log of x. Okay, now write solution. What is given? Find the second order differentiation of log x, means we have to differentiate log x twice. So now write solution. Let y is equal to log of x. What is given? Log of x is given. We have to differentiate log x twice because we have to know find the second order differentiation of log x. So write first y is equal to log of x. Name this one as equation 1. Okay. Now differentiating y. Differentiating y with respect to x. With respect to x, we get dy by dx is log x differentiation is 1 by x. So name this one as equation 2. So we got dy by dx. Now differentiating this one again with respect to x, because we have to find the second order derivative. Differentiating again with respect to x, we get d by dx of dy by dx is equal to differentiation of 1 by x, d by dx of 1 by x. So this one is nothing, it will become dy by dx, d2y by dx square is equal to, I am using here quotient rule, which is I'm writing here quotient rule. Quotient rule is, we know that u divided by v dash. Differentiation of u by v is v square. First v square. So keep v as it is. Differentiation of u minus u as it is. Differentiation of v. This one is known as quotient rule. Quotient rule and differentiation. So I am using this rule here. Then so x square, square of the denominator term, x square. So first keep first term as it is, second term as it is. Second term is here x, and do differentiation of first. Differentiation of first term is differentiation of 1. 1 is constant here. So differentiation of 1 is 0. Minus, keep 1 as it is, keep first term as it is, into differentiation of the second term. Second term is here x. Differentiation of x is, we get 1. Okay. Now is equal to x into 0 is 0 minus 1 into 1 is 1 divided by whole divided by x square. So finally we get 0 minus 1 is minus 1 divided by x square. So this implies d square y divided by dx square is equal to minus 1 by x square. Minus 1 by x square. Write this in a one box. So we get d2y by dx square as minus 1 by x square. Okay. So what is given first, write what is given to you in the solution, what is given to you, then write differentiation of y with respect to it, again differentiating because we have to find the second order derivative. Then we are using here quotient rule, this rule. Then we will get finally d2y by dx square as is equal to minus 1 by x square. So now write another example, which is, now write another example. Find the second order derivative of find the second order differentiation of y is equal to x cube plus tan x. Now write solution. Always in solution first write what is given to you, then go for what we have to find. What we have to find, second order differentiation of y is equal to x cube plus tan of x. Okay, write first given y is equal to x cube plus tan of x. Okay, now differentiating y with respect to x, we get with respect to x. With respect to x, we get dy by dx. Dy by dx is dy dx of x cube plus tan of x. dy by dx of x cube plus tan of x. Now differentiating this, x cube differentiation is by using x raised to n formula, 3 into x raised to 3 minus 1, you will get 2 here. Okay, plus tan x differentiation is sec square of x. Okay, now differentiating dy by, we got dy by dx as 3 into x square plus sec square of x. Now name this one as equation 1 and this one as equation 2. Differentiating equation 2 with respect to x, once again we get differentiating equation 2 with respect to x, we get d2y by dx square dy by dx of dy by dx into is equal to d by dx of 3x square plus sec square of x is equal to dy d2y by dx square is equal to differentiation of this term. 3x square differentiation is 3 into 2 is 6. 6, or I am writing here 3 2x. Differentiation of x square is 2x plus. So x square differentiation is 2 into sec x. This one is, suppose x square is x square. So x square differentiation is 2 into x. Okay. Now sec x is a trigonometric term. Again we have to differentiate sec of x. Then we get sec x differentiation is sec x into tan x. Sec x into tan x. Okay. Now 3 into 2 is 6. 3 2 is 6 x plus 2 as it is. We are now we have to multiply sec x into this bracket. Okay, sec x into sec x is sec square of x into tan of x as it is. So finally we will get, this implies d2y by dx square is d2y by dx square is 6x plus 2 sec square of x into tan of x. So okay, we are differentiating here y with respect to x. Tan x differentiation is sec square of x. So 3 into x square is 3 into 2x. So sec x differentiation. Don't get confused here. Suppose x is one term x square. Then x square term differentiation is 2 into x. Sec x. Okay. Now sec x differentiation. Sec x is a trigonometric term. That's why we are differentiating again. Then we will get sec x into tan x. Sec x differentiation is sec x into tan x. Then multiply, we will get this answer. Okay. Now write down another example. Same, finding second order derivatives. Now write so write down another example. If y is equal to, by third example, If y is equal to a sin x plus b cos x, then prove that what we have to prove, b square y, then prove that I'm writing here b square y plus d square y by dx square plus y is equal to 0. What is given? If y is equal to a sin x plus b cos x, then prove that d square y divided by dx square plus y is equal to 0. Okay. Now write solution. What is given first? Write given y is equal to a sin x plus b cos x. It is given. Okay. Now differentiating y with respect to x. We have to differentiate. Name this one as equation 1. Differentiating y with respect to x. Y with respect to x, we get dy by dx as dy by dx is equal to, keep a is constant, write a as it is, differentiation of sin x is cos x, plus b is constant, keep this one as it is, differentiation of cos of x is minus sin x, or you can write dy dx of a sin x plus b cos x. Okay. Now differentiating sin of x with respect to x. A is constant. Differentiation of sin of x with respect to x. Sin x differentiation is cos x, plus b is constant. Keep it as it is. Differentiation of cos with respect to x. Differentiation of cos of x with respect to x. Cos x differentiation is minus sin of x. Right, minus sin x. Okay. It is equal to a cos of x plus into minus is minus b sin x. So this one is dy by dx. So name this equation as equation 2. Now again differentiate equation 2 with respect to x, because we have to prove that d2y by dx square plus y is equal to 0. That's why differentiating equation 2 once again with respect to x. Differentiating equation 2 with respect to x, we get, once again differentiate equation 2. So we get d by dx of d2y by dx square is equal to d by dx of a cos x minus b sin x. Okay. D differentiation of dy by dx is nothing but d2y by dx square is equal to, now write a as it is. Differentiation of cos x is a as it is, because a is constant, keep a as it is. Differentiation of cos x is minus sin x into minus. B, keep as it is. Differentiation of sin x is cos of x. Write this one. Okay. Now write minus of a sin x. Multiplying these two, you will get minus of a sin x into minus b cos x. Okay. Now I am taking, we will get d2y by dx square as minus a sin x minus a sin x minus b cos x. Now I am taking minus sign from the right hand side. I am taking a minus sign common. Minus sign common, then we will get minus a sin of x plus b cos of x. Okay. Now d2y by dx square we got d2y by dx square we got this one as d2y by dx square is minus a sin x plus b cos x. Okay. What is minus a sin x plus b cos x? A sin x plus b cos x is nothing but y. Is given. Name this one as equation 3. Now I am writing the value of y here. Putting instead of a sin x plus b cos x, I am writing this one y. Okay, by using equation 1. d2y by dx square is equal to minus y. So this implies d square y d2y by dx square plus y is equal to 0. Or I am writing here. Lastly, we got d2y by dx square as minus of y. Okay, now d2y divided by dx square is equal to minus y. I am taking this minus y on the right hand side. I am shifting minus y on the right hand side to left hand side. It will become plus y is equal to 0. Hence, we proved d2y by dx square plus y is equal to 0, which is we have to prove d2y by dx square divided by d2y by dx square plus y is equal to 0. Hence, we proved it. The example I have taken. So, write down another example. Same differentiation of first we have to find first what is given to you, write down, then find the differentiation of y. Here we are having trigonometric term, so differentiation of sin x is cos x and the cos x differentiation is minus sin x. So simply if you know the differentiation of algebraic differentiation of trigonometric differentiation formula, logarithm differentiation formula, then you can easily solve this example. So if you want to perfect all these, then we should have to practice it on the regular basis, then you will get perfect. So write down another example. If you have any doubt, you can ask me. I will explain once again. If you have any doubt, you can ask me. I will explain once again. Or if you have any other examples, problems based on this second order derivative, you can send me your question. I will solve it. Inshallah, I will try to solve it and I will show you in the next class. Write down another fourth example. Now write fourth one. If y is equal to 3 e raised to 2x plus y is equal to 3 e raised to 2x 2 e raised to 3x, then prove that what we have to prove, d square d2y by dx square minus 5 dy by dx plus 6y is equal to 0. Here we have to find, here we are having y in terms of exponential term. So y is given in terms of exponential time, means e raised to the power 2x, e raised to the power 3x. So y is given in terms of exponential term. So we have to prove that d2y by dx square minus 5 dy by dx plus 6y is equal to 0. Okay. Now write down solution. First write given. What is given to you? Given y is equal to 3 e raised to 2x plus 2 e raised to 3x. Name this one as equation 1. Okay. Now differentiating y with respect to x, we get d2y, right? Differentiation of y, differentiating y, equation 1 with respect to x, we get differentiating equation 1 with respect to x, we get dy by dx is equal to 3 into differentiation of e raised to the power 2x is first 2 as it is, write 2 as it is, means we have to multiply the prefix of x. Prefix of x is x, 2 e raised to 2x plus, write this one in bracket, 2 3 into e raised to 3x. So if we have differentiation of, right, I'm writing here the differentiation of the e raised to a of x is nothing but a into differentiation of exponential term e raised to the power of a of x is a into e raised to a of x. Write this one as for your in your notes as rough column. It is the formula of finding the differentiation of exponential term. So I'm using this formula here. So finally we will get 3 to the 6 e raised to 2x plus 3 to the 6 e raised to 3x. This is dy by dx. dy by dx is 6 e raised to 2x plus 6 e raised to 3x. Name this one as equation 2. Now differentiating equation 2 once again with respect to x, because we have to find the second order differentiation. That's why differentiating equation 2 with respect to x, we get d2y by dx square is equal to, or I am writing here d by dx of dy by dx is equal to d by dx of 6 e raised to 2x plus 6 e raised to 3x. Okay, differentiation of dy by dx is d2y by dx square. Now differentiation of this one again, once again. So 6 as it is, differentiation of e raised to power 2x. Okay, plus 6 as it is, differentiation of the power e raised to 3x. Now Keep 6 as it is. Again, differentiation of the exponential term. We have a into power e of x. Differentiation is a multiplied prefix of the power prefix of x. A into multiplication of a into e raised to the power a of x. So I am using this formula 2 into e raised to 2 of x here plus 6 as it is 3 into e raised to 3 of x. So here 6 2s are 12, multiplying this one into 12 into e raised to 2 of x plus 6 3s are 18 into 3 of x. Okay, we got d2 over dx as dx as 12 e raised to 2x plus 18 e raised to power 3 of x. Okay, name this one as equation 3. Equation 1 we have which is given to us y is equal to 3 e raised to 2x plus 2 e raised to 3x. This one is equation 1. After differentiation we got equation 2 as dy by dx 6 e raised to 2x plus 6 e raised to 3 of x. Okay. After differentiation of the dy by dx with respect to x, we get once again 12 e raised to power 2 of x plus 18 e raised to power 3 of x. Now what we have to find? d2 over dx square minus 5. We have to prove that d2 over dx square minus 5 dy by dx plus 6y is equal to 0. So that means we have to multiply equation 2, which is dy by dx value. We have to multiply equation 2 with 5 and equation 1, which is y, with 6. Okay. Now multiply equation 2, or we can write this one. I am writing d2y by dx square. What we have to prove? Right, simply minus 5 dy by dx square plus 6y is equal to, now write, d2 by dx square value is 12 e raised to 2x plus 18 e raised to 3x. Okay, minus 5 into dy by dx value. Minus 5 into what is dy by dx? From equation 2 I am writing 6 e raised to the power 2x plus 6 e raised to the power 3x. Okay, plus 6y plus 6, right, plus 6. What is y value? Y is given to you 3 e raised to 2x plus 2 e raised to 3x. 3 e raised to 2x plus 2 e raised to 3x. Okay, now open this bracket, then we will get 12 e raised to 2x plus 18 3x minus 6 5 is 30 e raised to 2x 6 5 is 30 minus plus minus minus 6 5 is 30 e raised to 3x plus, now open this 6 into this whole bracket, 6 is the 18 e raised to 2x plus 6 2s are 12 e raised to 3x. Okay, write down d2 by dx square value minus 5 into dy by dx value from equation 2 plus 6 into y value with from equation 1. Then we will get, now we have to multiply whole term, then we get, finally we will get, I am writing here 12 e raised to 2x plus term I am adding 12 e raised to 2x plus 12 e raised to 2x. It will become, I am adding this term, don't get confused here. This 12 to e raised to 2x plus 12 e raised to 2x. It will become 30 e raised to 2x. Okay, I'm writing here 30 e raised to 2x. Okay, now I'm adding plus 18 e raised to 3x means how to add this term. We have to add the numbers which are having same exponential terms. E raised to 2x plus e raised to 2x. 18 plus 12 we will get 30. Now see e raised to 3x plus 18 e raised to 3x plus 12. These two terms. These two terms. Okay. E raised to 3x, e raised to 3x. Both are having same exponential term. That's why we can add 18 plus 12 plus 30 plus 30 e raised to 3x. Okay. Now write remaining what is minus 30 e raised to 2x minus 30 e raised to 3x. This one is 3x. First e raised to 2x term I have added, and now we have secondly we have added e raised to 3x term. Then we will get plus 30 e raised to 2x plus 30 e raised to 3x. Now this one we got by multiplication of phi of dy. So minus 30 e raised to 2x minus 30 e raised to 3x. Okay, now we can cancel each term. Plus 30 e raised to 2x and minus 30 e raised to 2x. These two terms get cancelled, and 30 e raised to 3x and 30 e raised to 2x. These are both are cancelled. We can cancel it. So because we have plus and minus values, so finally we have zero value. Okay, this implies d2y by dx squared minus 5 dy by dx plus 6y is equal to 0. Finally we got it. Okay, it's very simple. Just what is given to you, exponential term is given to you, and this one is x. Don't get confused. This one is x. First we have to differentiate it with respect to x, then again differentiate. After differentiation of first and second derivative, we have to use what is given to you, d2y by dx square minus 5 into differentiation of y with respect to x plus 6 into given value of y. Then we will get, after simplification, we will get finally these one as 0. Okay, with this I will stop. I will continue in the next class, inshallah. If you have any doubt regarding second order derivatives, explanation or any example, or if you have another example, you can ask me. I will show you the solution. And one thing I want to say, if you want to perfect all these terms, second order derivative, differentiation, then you should have to practice it on the daily regular basis. Okay, thank you.